Hi there, this is Dr. Rhonda Cofelt, and welcome to Chapter 4 of our Julia Burge textbook. And in this chapter, we're going to look at reactions that occur in aqueous or water-based solutions. So in part 1, we're going to look at compounds and see if they are non-electrolytes, weak electrolytes, or strong electrolytes, and how we can make the decision as to which one of those they are. So first, let's talk about a solution. If you recall, an electrolyte is a solution that can conduct electricity. So a solution is a homogeneous mixture of two or more substances. You've got a solute, which is what's present in the smaller quantity, and a solvent is what is present in the larger quantity. And so we've seen that this can be gases and gases, it can be solids and liquids, but in this particular one, a solution is going to be an aqueous solution, that is where the solvent is mostly water. So as we said, an electrolyte is a substance that will dissolve in water and it will conduct electricity, and it typically is going to do that because it has ions contained in that solution. A non-electrolyte is a substance that dissolves in water, but the solution does not conduct electricity, so that is to say it does not ionize or form ions. So sucrose, for example, is an organic molecule, C12H22O11, and that is table sugar. Okay. Sucrose does not break into ions, so it is a non-electrolyte. Sodium chloride, on the other hand, which is an ionic salt, breaks apart in a solution to become ions, and so it is going to release sodium ions and chloride ions in the presence of water, and the presence of those ions is what allows it to conduct electricity and therefore makes it an electrolyte. So dissociation is the process where an ionic compound, when it's put into water, will break apart into its constituent ions. So sodium chloride solid becomes sodium plus and chloride minus in its aqueous ion form. Ionization is a process where a molecular compound forms ions when it dissolves, and we see this in the case of strong acids, which will break into an H plus or proton and a chloride. So acids are one of the two most important classes of molecular compounds that are also electrolytes. So if you recall, they are going to dissolve in water and produce hydrogen ions, okay, and that's what makes them an acid. That's why we write that H, that ionizable hydrogen, or dissociable, I should say, hydrogen at the beginning of the formula. Molecular bases are also one that will dissolve in water and produce hydroxide ions, and so they too will conduct electricity. An electrolyte that dissociates completely is a strong electrolyte, and you're going to see a single arrow showing that it completely dissolves and all the solid from NaCl becomes a sodium ion and a chloride ion. All water-soluble ionic compounds dissociate completely when you dissolve them, and they are all strong electrolytes, and those are going to be the strongest ones you see usually. Molecular compounds that are strong electrolytes is a very short list, okay? And they are going to be your strong acids and strong bases. So your strong acids are hydrochloric, hydrobromic, hydroiodic, nitric, chloric, perchloric, and sulfuric acid, the first ionization. Okay? So, though, if you know those acids, if you see another acid, then it's weak. So you should commit these to memory so you know the strong acids, so you can recognize the weak acids by, it's just a process of elimination. So you only have to know these 7, and if you know the 7 strong, then you also know that everything else is a weak. If it's not on that strong list, it's weak. Most molecular compounds are going to be weak electrolytes. Okay? A weak acid, such as acetic acid, not on the strong list, is going to ionize partially, but a lot of that, it's going to remain in its molecular form. Okay? So we put a double arrow here, and that is what shows us that it is in a dynamic equilibrium. That is, it's going back and forth between the molecular and the ions. Okay, so even though it does split into the H plus and the acetate ion, most of it is going to remain in its molecular form. And so that's why you have the double arrow, because it's not a single arrow all the way to the right like you have strong acids. That shows everything ionizes. In this, just a small amount will ionize. And so that's why you have the double arrow. Ammonia is a weak base, and it's very similar to a weak acid, so that it maintains some of its molecular form, even though it's a gas in this case. Okay, you'll have ammonium and hydroxide in the aqueous form, but it will have a double arrow because most of it does not ionize. So if we're wondering about if a solution is a strong electrolyte or a weak electrolyte, we can use what's called the light bulb test. Pure water, which contains no ions, will, if you form a circuit, okay, with cathode anode, it will not conduct electricity. If you put a weak acid in there, or a weak electrolyte, a small number of ions will form, and so the light will be dim. Sodium chloride, which is a soluble ionic salt, contains lots of ions, and so the more ions you have, the brighter the light. And so that's how you can actually figure out how strong the electrolyte is. So if you look at a compound and it is ionic, chances are it's going to be a strong electrolyte. Molecular, chances are it will be a weak electrolyte or a non-electrolyte. Okay? Because an ionic compound has a cation, which is positive, and an anion, which is negative, okay, it's going to probably conduct electricity as long as it can dissolve in the water. But it must dissolve in the water. If it does, it's a strong electrolyte. If it does not contain a metal cation, or it's not the ammonium cation, it must be molecular. And so in this case, you have to figure out, is it an acid? If it's an acid, if it's a strong acid, it will probably be a strong electrolyte. So if what we've seen so far is very soluble ionic salts are going to be strong electrolytes, and strong acids are going to be strong electrolytes. And this is just kind of a flow chart showing you where that logic tree is. So we're going to apply that information, because I won't say, okay, what is the definition of this or that? You're going to have to apply that information. So in the case of methanol, methanol doesn't have a metal in it, okay? Even though it does have a hydroxide, it is not a base, okay? It just happens to have a hydroxide. So it is a non-electrolyte. Sodium hydroxide, which is going to split to sodium and hydroxide ion, is a strong electrolyte. Ethylamine is a weak base, so it's going to be a weak electrolyte. And then hydrofluoric acid, which is not one of the strong acids, is going to be a weak electrolyte. Here's a list for you to look at and figure out, is it a soluble salt, ionic salt? Is it a strong acid? Is it a molecular form? And so you can apply those concepts to what we just did and see, and you can use this flow chart, and it's blown up bigger in the previous slide, to kind of figure out if it's a strong or a weak. All right, when we come back next time for part 2, we're going to look at, we said things dissolve in water. We're going to look at how soluble something is. There are rules that we can predict whether or not something will dissolve in water, and then in that case, if it doesn't dissolve in water, it forms a solid in water, and it will form what's called a precipitate in a precipitation reaction. So join me for part 2 as soon as you can.